Okay, let's go ahead and take a look at these. So the first one, the probability is chocolate given you pick the male. So you're, oh sorry, I did that one already, didn't I? Did I do that or did I not? I didn't. No. Given you pick the male, so that means that you know it's one of these 12. It's not a female. So what's the probability that it's chocolate? 5 out of 12. So, everybody with me on that part? Probably pick a male puppy or a black one. So how many males are there? 12. Black puppy, 6. But again, this 3 is getting counted in the 12 and the 6. You have to subtract it out. So 12 plus 6 minus 3 out of 20, which is 15 out of 20. Or you could have just added up. You could have just added up those 4 spots. You could have said, oh, this plus that plus that plus that, and just added them. That's fine too. Okay, next. The probability is female given you picked a yellow lab. So if you picked a yellow lab, that means you definitely know it's one of these, not those, not those, right? So what's the probability that it's female? How many females are there? 2 out of 6. Okay, so far? Probability it's chocolate, given you picked a female. So you know it's a female. Probability it's chocolate is 3 out of 8. Okay, do you guys need 15 seconds with your neighbors, or we're good to go? Okay, we got a couple more things to cover. Okay, I think we can get out of here on time. Let's stay focused. I've got a few things to cover. So, experimental or observational probability. What if we don't know the exact probability of something? So, we can estimate the probability by taking a sample and from that frequency figuring out the frequency of the event divided by the total frequency. So here, for example, I don't know what the probability of someone is having O-type blood, but I can sample 50 people, and how many had how many had O blood out of the 50? 21. So I would guess that the probability of someone having O-type blood is 21 out of 50. Do you see where we got that from? Is not going to be ever perfectly correct. Let's get a reader. Vanessa C. Go ahead and read.
Note that experimental or observational probability is not always the same with the population. In the previous
Right, keep going.
In the previous example, the surveyed students might not match the entire school exactly.
Right, we sampled 50 people. They may not match the whole everybody. Keep going.
If I were to flip a coin 10 times, I might get 4 heads, but the true probability of heads is not 4 out of 10.
Right, it's a sample. Samples vary. I'm sure you guys are all aware of that. All right, so let's go through some probabilities. Rule number 1. The probability of any event is between 0 and 1, or 0% to 100%. 100% is 100 cents, that's 1. Right, 0 to 100%, 0% to 100%, or decimal-wise 0 to 1. We denote that by saying the probability of E, again, capital P means probability, and then parentheses of, probability E is between 0 and 1. It's greater than or equal to 0, less than or equal to 1. So the main rule from this is it probably can't be negative. You can't have a negative probability of something happening. You cannot have a greater than 100% chance of something happening either. Right? The most likely can be is 100% chance. Moral of the story, if your probability is like 7 on a test, you're probably leaving out the out of, 7 out of 20. Rule number 2, the sum of all probabilities and outcomes in a sample space is 1 or 100%. Can't have 50% chance of heads and 25% chance of tails without anything else in there. All the probabilities have to add up to 1 or 100%. These are pretty straightforward. I'm going to jump through them quickly. If something is impossible, its probability is 0. If something is certain, absolutely definitely true, then its probability is 100% or 1. We're going to skip lab problem 3 and 4. Just skip through those. We're skipping 3 and 4. There's 2 more things I need to cover for your homework. One is the complement of event E, denoted by E bar. Mathematicians are very boring. E with a bar over it, E bar, is a set of outcomes that are not included in the outcomes of E. In other words, the complement of E is everything that's not E. It's also written E complement with a little C up there. Note a couple of things. The probability of an event plus the probability of its complement equals 1. In other words, the probability of something happening plus probability of it not happening should equal 1 or 100%. Which means that you can find the probability of an event by doing 1 minus the probability of its complement. I will show you what we're talking about. For example, you sample a bunch of people. 23% of them have vanilla as their favorite ice cream. If you randomly pick somebody from that group, what's the probability that vanilla is not their favorite flavor of ice cream? 77%. How do you find that? 100% minus 23%, you get 77%. Everybody understand that? Good, you guys are all good with that. The last thing we have to talk about before I let you go, there's 2 more things. The probability that a person does not have type AB blood. How can you find that? Here's AB. What's probably they don't have AB? There's 2 ways of finding it. What's one way?
Subtract that from the total.
Yep. So you could say 1 minus the probability they do have AB, right? So that ends up being 48 out of 50. Or you could just add these all up. You could add up the rest of these. 22 plus 5 plus 21 out of 50, which is the same thing. Which one's easier?
1 minus.
Yeah, 1 minus. That's a lot easier. And then the last thing we need to talk about before you go, because you need to know it for the homework, is, sorry, wrong one, is mutually exclusive. So 2 events are mutually exclusive if they cannot occur simultaneously. For example, a puppy cannot be a black lab and a yellow lab at the same time. They're mutually exclusive. There's no overlap between them. However, a puppy can be a black lab and a male lab at the same time. It can be male and a black lab at the same time. So those would not be mutually exclusive. Black and male. Good? But black lab, yellow lab, mutually exclusive. They have no overlap. They can't have anything in common. Which is why, when you said what's probably they're a black lab or a chocolate lab, you just added them. If you say what's probably that they're a black lab or a male lab, you add the probabilities, but you have to subtract the overlap. Right? Remember we subtracted out the ones they had in common. All right, that's it. Have a good weekend. Should be all